Hi everyone, welcome to your math lesson for today. I want to take some time and go over the standards that we're focusing on this week and really take a minute to dive a little bit deeper and make sure that you guys are really understanding what the standards are asking you guys to do. So this week we're talking about angles, and we're recognizing that angles are formed whenever two rays share a common endpoint, which we call a vertex. So that's what an angle is made up of. And then I also want for you guys to understand, if we're looking at this very first element right here, an angle is measured with reference to a circle. So what do we mean when we say that is that we have a circle, okay, this is my circle here, and that an angle, all of these have this common endpoint right here, and then we have rays coming out of this circle. Right here, this from here to here is, we know, a right angle, 90 degrees. And then if I go down from here to here is another 90 degrees, so that would make this 180. And then if I make another rotation here, from here to here is another 90. And so we're at 270. And then from here to here is another 90. So finally we've done a 360. We know 360 degrees are in a circle. And so now we've gone our full way around a circle using 4 different 90-degree angles. So an angle that turns through 1/360th of a circle is a 1-degree angle. This circle is made up of it's made up of 360 1-degree angles, and we can use each of those 1-degree angles to measure this whole circle, okay? So an angle this whole circle is made up of angles. Okay, so we're going to talk a little bit more about that now. When I'm taking a look, like I said, I want for you guys to know and for you to use that vocabulary. An angle is made up of those 2 rays connecting at a vertex, and think about it as a circle. Think about each of those angles are on that circle and they're connecting at that vertex right there in the middle. They all share that common endpoint right there. Now, if we take a look at the different types of angles, this is a review for you. I know we've talked about this. We have acute angles. We have, which are less than 90 degrees. We have right angles, which are exactly 90 degrees. We have obtuse angles, which are greater than 90 degrees. We have our straight angle, which if you look at this and you come back here, our straight angle, if we think about this, is 0 degrees, and going straight down, you can see it's going to be 180 degrees, that's straight angle. We have that reflex angle, which goes greater than 180 degrees. And then a full rotation, which we know a full rotation around this circle is going to be 360 degrees. Even if this is not, when I showed you the other example, I had the start point up here. Doesn't matter. If this is 0 and 360 lined up, if you go a full rotation, it's 360 degrees. Okay, so I want for you guys to understand that angles go through this circle. This circle is made up of 360 1 degrees. If this is a right angle, it is made up of 91 degrees, okay? Not 91 degrees, 91 degrees, okay? Taking a look now, moving on to this next standard, if we know that the angles are measured around the circle, now we need to figure out how to measure these angles using a protractor. And you guys practiced a little bit with this on Monday, but I'm hoping that this clears up any misconceptions that you might have, okay? So let's go ahead and let's take a look at this protractor. And I know this is tricky doing it at home, because if we were in school, we would all have our protractors out and we would all be measuring actual angles. If you have a protractor already, maybe you have an older brother, sister that has one, take it out and use it. But if you don't have one, that's okay too. You're going to get a chance to use a protractor, but what I want for you to do right now is I want for you to just kind of take a look with me so I can go over the protractor a little bit more, okay? When I look at this protractor right here, you can see that there's two sets of numbers, okay? It kind of looks like a ruler. We're counting by tens, increments of tens here. And you can see that it goes through a straight angle, so that 180 degrees, and it goes up, 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 and around, right? And in our increments of 10, starting at 0 and going over to 180. But what can be confusing is that over here, it also has a 0 and goes to increments of 10. And I'm going to show you why the protractor is like that, why the protractor has those two different sides, okay? Why the protractor is like that. So if I take, I'm still in this, so I'm going to take out of that. Okay, so I have right here this, this is one of my rays, okay? So I'm going to create an angle. I'm going to start, one angle has to start on 0, or one ray has to start on 0, and then my other ray can go wherever. I can make any kind of angle I want. You can see right here in the middle, as I move this ray, the numbers change, okay? And you might be saying, but I don't understand why, or I don't understand how we get the numbers. Well, let's go ahead and let's create an angle. Okay, there we go. I've created an angle right here. I've put two rays down. There's the angle that I created. It pops out when I do that. And you can see that the angle is 42 degrees. Well, how did I know that? Well, the first thing that I need to do, and I put this on my helpful hints thing, the first thing that I need to do is I need to look at this and I need to say, okay, this is an acute angle. So I know it's gonna be less than 90 degrees. Also, because this ray right here is on 0, it makes sense for me to count from 0. Doesn't make sense for me to count backwards from 180, right? So it makes sense for me to start here at 0, and then I'm going to count just like a ruler. 10, 20, 30, 40, and then those little tick marks after, I can see it's 41, 42 degrees. And that's how I get this 42 degree angle. Now, let's take a look. Now I'm keeping my one ray on 0, my other ray gonna go up here. I've now created an obtuse angle. So I automatically know I'm gonna look here, 0, and just if I know this is an obtuse angle, it wouldn't make sense for my answer to be in between, if I looked over here, in between 50 and 60, right? Because that doesn't make sense for an obtuse angle. An obtuse angle has to be measured in, it has to be measured greater than 90. So I know that using this set of numbers doesn't make sense right here. But when I look up here, now I can see that it goes in between 120, 130. I'm gonna count those little tick marks and I get right to 124 degrees. Let me show you an example of what it would look like if one ray was over here, okay? So now I'm moving it over here and now my one ray is over here, but see now it's still on 0. It's just now I'm using the inner set of numbers because it's going this way. So now when I shoot out this angle, it's calling it a reflexive one. So it's using a little bit different parameters there, so you can come out to the full circle there. I'm going to look at it using, this is an acute angle, okay? And when I count up, now I'm going to go 0 to 10, 20, 30, 40, 50, and it looks like it's 51, 52, 53 degrees. So do you see now how I can use this angle, and that's when I would use this inner set. I can do it again here. I have this angle, starts right here, comes out here. I'm going to use the inner set because my 0, this is always my starting point right here, my 0. 10, 20, 30, da, 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 in between 140, 150, it looks like it's right at 146 degrees. So that angle would be 146 degrees, all right? So I hope that clears it up just a little bit. This is an example that I've taken straight from your My Math book, but you can see when you're using a protractor, there's a little circle right in the middle of your protractor. It's right right in here, and that's where you put that vertex, that point that's like in the middle end, that end point right there. You put it right in the center. You line it up to make sure that it's on 0. One ray is on 0, okay? And then you figure out, am I going to count, if this is on 0, then that means I'm going to use the inner one. If it was the other way, we would do it the other way, okay? So you can see these are just step by step by step how you would use a protractor. I want to go ahead and show you guys this example. So if I have this angle right here and I need to take a look at it, the first thing I'm going to do, I'm going to line up my protractor. So I'm going to find, you know what, I wish I could, I'm going to move this bad boy down here and I'm going to line up my protractor. So here it is. I've got my vertex right in my middle center part right there. But the problem with this is that I don't have my angle on 0. I don't have one of my rays on 0. So I am going to have to rotate it just a little bit to make sure that it's on 0. Now, when I look at it, I've got this one on 0, so I know I'm going to use this inner part right here. I already know this is an obtuse angle, so I know that anyway, but I'm going to use this inner part right here. And when I use this inner part, I come up here, and I come all the way up, and I can see it's in between 120, 130. If I extend it just a little bit, it looks like it extends right into the center point, so 125 degrees. And look at that. When I check myself, I can see that it is 125 degrees. So I hope that clears things up for you guys a bit. I hope that that makes sense. If you're still having some trouble with protractors, please let me know so we can take a look at it together. It will be so much fun once we get our protractors out, and you will, in 5th grade, you'll get to get those protractors out and you'll get to do some exploring with that too. All right, guys. Talk to you next time.